Good morning, welcome to
Hey,
AP
Kennedy.
Stats. We are doing a practice hot dog question. And the practice hot dog question had the answer of what? Raise your hand if you think you know whether it's A, B, C, D, or E. Lewis?
I think it's E.
I'm sorry, E?
Yeah.
Okay, so a controlled experiment. And so how many of you agree with E? That a controlled experiment is most useful in establishing a cause and effect relationship. A lot of you picked E. How many of you picked something else? You think something else is the correct answer. Now, for those of you watching on video, you might want to take a screenshot of this. This is the actual question, so take a screenshot and study it. Now, which of the following is most useful in establishing a cause and effect relationship? If you picked E, that is correct. Why didn't you pick D? What? D was a well-designed, well-conducted survey incorporating chance to ensure a representative sample. Lewis?
D could prove an association, but cannot exactly prove a cause and effect
Yeah, so
relationship.
D was great for establishing an association. It's very deceptive because the longest answer was D, and sometimes it's like, well, if I don't know, just go with the longest answer, right? Isn't sometimes the longest answer the one that's
I
correct?
go with the shortest answer if I don't know.
You pick the shortest answer if you
Yeah,
don't
because I
know?
never know what the longest answer means.
Okay. Well, in this case, the answer was the second shortest answer. So, controlled experiment. Any questions on why a controlled experiment is the best way to go? Okay, so that was your warm-up hot dog question. Now for the real deal. This is an actual hot dog question. And write down either A, B, C, D, or E. The question is, a study of Parkinson's disease. In a study of Parkinson's disease, 100 volunteers had incisions made through their skulls. The patients were randomly sorted into two groups, one of which had the new drug inserted into the brain, and the other group, the skulls were closed with no treatment given, although just opening the skull is a treatment. The patients did not know who received the drug. In the weeks to follow, all 100 volunteers showed similar improvement in physical condition. What is this an example of? A, the effect of a treatment unit. B, the placebo effect. C, the control group effect. D, sampling error. E, voluntary response bias. Talk about it. This is the hot dog question.
Yeah, it's okay. I'm pressing you. I hope so. Do you have a better? Hot dog.
Oh, I got missed.
Okay, good.
Yeah, right. Trust
All
me.
right, thumbs up on this one.
Oh,
Now.
yeah, you're right. I'm so proud of us, right? Yeah, no, I had very good
Did you guys both have to sign off on
I did. I trusted her, but I
She just trusted you. I mean,
Correct answer is B as in boy.
Our first dub.
Please come and retrieve your hot dog bun now.
You do better, but
Sorry, it was me not understanding.
no, it's okay.
So in this particular problem, correct answer, B as in boy. If you're watching on video, just take a screenshot here of the question so you can study it. But the point is that the placebo effect is a real effect. The New York Times did, New York Times Magazine, I believe it was, just did an article within the past week about the placebo effect. And
I
I
saw
would be
that actually.
surprised if it, what you say, you read it?
No, I didn't read it, but I saw it. And I
So,
thought it was fun.
You didn't read it. Placebo effect,
I read it.
New York Times. Should come right up.
It was in my phone.
New York.
And what is the,
I do.
what if the placebo effect isn't a trick? This is what was in the New York Times Magazine, and they were just talking about how they actually did a nice job of defining placebo effect, and basically they talked about how if someone receives a treatment from someone they know and from someone they know who cares about them, then they get better. It's a real effect. And so if you're gonna have an effective drug, it better do better than the placebo effect, because the placebo effect is real and it's gonna help people. So there's a nice read there in the New York Times Magazine that came out just recently. I don't know if they have a date on this. It's November 7th of 2018. The next hot dog question is, oh, by the way, do you have any questions on this particular problem in which the answer was the placebo effect?
Yes.
Yes, Lewis.
Why doesn't C work?
Okay, so the control group effect doesn't work because it's not a thing. It doesn't, in order to do something, in order for the control group effect to operate, it has to first exist, okay? There is no control group effect. There's a placebo effect, but there's not a control group effect. It's a made-up thing to distract you from the placebo effect. All right, so. Next question. I'm going to put it up here so that people watching on video can take a screenshot of the question. Okay, so here's the next question. This is the hot dog question. It says, 50 migraine patients are randomly selected from hospital records. Half the patients are told to drink ice water and sit in the dark when they next experience a migraine. The remaining patients are told to use neither of these possible remedies. Participants then report back as to relief, if any. Serious faults of this experimental design include which of the following? Roman numeral 1, lack of randomization. 2, probable confounding variables. 3, lack of blinding. Multiple choice, pick either, talk about it, write down either A, B, C, D, or E. On. I wasn't full. This is not the open face sandwich. So that's 2. You're tied for second. 3. Put it up on the slide right now, so it's disqualified.
Wait, if we did right, take that
You
back.
never know that. So put
I really want
1.
to
So
Put it there.
not be perfect.
I don't know.
And
I'll put on
alrighty. Well, all the responses are in. And what I'm seeing here for responses are, I'm seeing E's and B's and E's, 2 and 3. Okay. First of all, let's read this carefully. 50 migraine patients are randomly selected from hospital records. Okay. We usually ask for volunteers, but here we randomly select. That was deceptive. They were trying to trick you into thinking that randomization was involved in this experimental design. They used randomization to get the people, but randomization in an experiment requires that once you get your people, whether they volunteer or whether they're randomly selected, you have to randomly assign them to treatments. It just says half of them were told, half the patients. How did we decide which half are told to drink ice water? They didn't tell us that they randomly assigned half of them to drink ice water. So that's a sneaky way to word the question, because there is a lack of randomization in this problem. There's a lack of randomization. When it comes to experiments, it's got to be random assignment of subjects to treatments. Okay, now they sit in the dark. Sit in the dark when they experience. The remaining patients are told to use neither of these possible remedies. So there's probable confounding variables. Which variables are found together? Confounding means found together, so making it hard to tease out which variable is actually causing the effect.
Water in the dark.
Water and darkness are confounded. Okay, they're together. So which is it that really made the migraine better? Was it the water or was it the darkness? There's confounded variables. Lack of blinding. Well, participants are serious faults of this experiment include. So let's take a look at what the authors think the answer is. They picked D, as in dog. Why? Well, there is no indication, and I'll let the people at home take a screenshot of the answer, so screenshot that. Okay, And now, for the studio audience, there is no indication that randomization is being used to decide which patients have the treatment of ice water and darkness and which patients are in the control group. So there's two treatment groups, but we don't necessarily have random assignment. If the treatment of ice water and darkness helps, there's no way to tell whether ice water or darkness or the combination of both is responsible. So those variables will be confounded. Lack of blinding is not a design fault here because blinding is impossible in this experiment. You can't be blinded as to whether or not you're in the dark or in a non-dark room. It's like if that's one of the treatments, we can't blind you to that. Unless we blindfold you, but then you may as well be in the dark. So it's when blinding is not possible, it's not a fault. So I love these hot dog questions. So you can bring issues to the front and go to sleep. Come and get your hot dog bun now. Pretty much everyone got sheep around that one.
That was never heard. That was funny, Mr.
Thank you. And now, let's talk about the big picture issue with experiments. Now, I'm handing out to you Floyd Bullard's all-time favorite AP problem for AP Stats. Floyd Bullard is a storied AP Stats teacher who was characterized by one of my colleagues at Stevenson High School when he saw Floyd Bullard talking. It was like tattooed head to toe. My colleague, speaking of Floyd Bullard, said, Floyd Bullard, he's one weird dude. Said. And but Floyd has great insight into how to teach experiments using the concepts of signal and noise. If you were to Google Floyd Bullard signal noise, you would be able to read really a fantastic essay on how signal and noise can be used to teach some of the most challenging AP Stats concepts, like number 2 from 2002, which reads, a manufacturer of boots plans to conduct an experiment to compare a new method of waterproofing to the current method. I've given you some advanced descriptions of this. This is a famous problem in AP Stats teaching lore. The appearance of the boots is not changed by either waterproofing method. The company recruits 100 volunteers in Seattle, where it rains frequently, to wear the boots as they normally would for 6 months. At the end of the 6 months, the boots will be returned to the company to be evaluated for water damage. So suppose to evaluate them, they fill the boots up with water, let them sit there for 24 hours with a cup underneath them, collecting any water that leaks out of the boots. So their response variable is the number of ounces of water that leaks out of the boots after 6 months of wear. And then maybe they're really going to be looking at the mean number of ounces that come out on one waterproofing method compared to the mean number of ounces that come out on the other method. Describe a design for this experiment that uses 100 volunteers. Include a few sentences on how it would be implemented. Could your design be double-blinded? Explain. Notice that the farther you go in mathematics, the fewer numbers there are and the more words there are. The numbers are almost completely gone. Now you're writing essays. Welcome to higher math. So, as you're looking at this problem, let's just talk about what is signal in general. So would you please flip to the back side of this famous AP Stats problem on experimental design and write the big question, what is signal? Now, signal is in quotes because you should not use the word signal when you're writing your essays for AP Stats. What is, quote, signal? And just give you a heads up here, signal, we've talked about it a lot, but signal is variation in the response variable. Variation in the amount of water that drips out of the boots over a 24-hour period, which is variable from boot to boot. Signal is variation in the response variable. Every time you write signal, put it in quotes to remind yourself you're not going to use the word signal. It's an important concept we're developing here, but you won't use signal on the AP test or on my test. This is variation in the response variable. Due to what? Signal is variation in the amount of water that drips out of these boots. That's due to what? I'm sorry? Factor. Which factor? Factor under study or factor not under study?
Understood.
Factors under study. Due to factor or factors under study. In this case, the factor under study is the waterproofing formula, which comes in two levels, waterproofing formula A and waterproofing formula B. One factor, two levels, and so there's two treatments. Now, would you please answer the question, what is noise? Write out your answer to the question, what is, quote, noise, unquote. My guess is that the answer has popped into your mind. It's just a matter of writing it down. Can someone tell me what you're going to write down? What sentence are you writing down in response to the question, what is noise? All right, Andrew.
Is it other things that get in the way, or might be like other causations?
It's something you can actually construct your answer in with parallel construction. It's basically use the same wording as here, except just a little bit different. Jasmine, you want to try it?
It's the variation in the response variable due to factors not under study.
Yes, that's what noise is. It's variability or variation in the response variable due to factors not under study. Now, in the Pardee Sabeti video that we saw yesterday, we heard Pardee use the phrase that the treatment groups, there were 5 treatment groups. What was it? It was, they were talking about various drugs for reducing pain. So what, oh yeah, chondroitin, glucosamine, the mixture of the two, and then
Placebo, and then like
placebo was the 4th one, and then like some other, there's other treatments, I guess, some other treatments. So there were 5 of them. And she said that those 5 treatment groups were as equal as random could produce. They randomly assign people. But when you're randomly assigning people to treatments where there's a lot of noise, where there's factors that are not under study that produce a lot of variation in the response variable, and when we think about this situation where the response variable, well, okay, what are sources of noise when it comes to things that could cause the waterproofing formula to break down? Clearly, perhaps this is not clear, but waterproofing formula A and waterproofing formula B may not really be all that different. There might be just a little bit of difference in the number of ounces of water that drips out of the boots between waterproofing formula A and waterproofing formula B, where all other things are considered equal. But all other factors not under study are not equal. What other factors can cause variation in the amount of water that leaks out of these boots? Use your imagination for a second. What are some factors not under study when it comes to wearing boots and breaking down the waterproofing?
the amount of rain in Seattle.
Okay, so amount of rain. We're brainstorming. That's good. Amount of rain in Seattle. And so, yeah. What else?
How often people wear the boots?
Okay. Amount of where? Amount where there's 100 subjects here. Some of them are gonna wear the boots every day. Some people are gonna be, maybe they're gonna get a 6-month illness where they don't use their boots at all. And so they don't wear them at all. What else? What other factors?
The job of the people wearing it.
Okay, your job, maybe these are students, so it could be their job as a student. Job of people, if your job is to play and tackle football in the mud, then maybe your boots are gonna get a lot more wear than the person whose job is to be a concert violinist, where you're hardly going outside at all, or at least, unless you're an outdoor concert. But yes, Peter.
Type of sock.
Yeah, so we've got, what socks are you wearing? Type of sock. So, some people have socks with, long, pointy, sharp spikes on them that tend to, cut through the boots. It's like, oh, now it's got all these holes in my breaches of the waterproofing system. So the type of sock can be a huge factor, at least in my imagination. What other factors could lead to variation in the response variable? Factors that are not under study.
If they have a puppy, the puppy's gonna start chewing on the boot.
Does this subject own a puppy? So we generally refer to this in the industry as puppy ownerage. Okay? So, all right. There's lots of factors, and you know what? These are noisy factors. And so even if we went with the Pardee-Sabeti, hope of having the treatment groups, maybe we have 2 treatment groups, have them as equal as random can make them. Well, you know what? Yeah, we want to evenly distribute puppy ownerage to the treatment groups. But that's a lot of variability. So whenever you've got super noisy factors that are not under study, that's when you want to consider blocking. Why do we block is the third question. Third question, okay. Why do we block? Is that one word, or it's actually 1, 2, it's 4 words. Okay, why do we block? Block is a word you can use on the AP test. We block when the factors under study cause a lot of variability in the response variable. Or we can say when the factors that are not under study are noisy. When we have many, or let's just not even say, if we have even one is enough. When we have noisy factors, noisy factors would be factors that are not under study that produce a lot of variability in the response variable. So, any questions on what this idea is of why do we block? Yes, go ahead.
If we have factors not under study that don't cause much variation, is that not considered noise? Do we just disregard that?
Yeah, they're not noisy. I mean, they're producing variability, but when you've got a variable that's noisy, it's like obnoxious and loud, it's like, come on, type of sock. That could really produce a lot of variability in the factor that's in the factor that is in the response variable. Yeah.
And we have noisy in quotation marks. What word do we use instead of that? Like, how would we phrase
Okay,
that?
so whenever you want to use the word noise on the AP test, you use the phrase variation in the response variable that is not under study. It's a long phrase. That's why Floyd Bullard is, let's just call it noise.
Okay.
Variation in the signal, or variation in the factor that is, variation in the response variable due to factors that are under study. That's your signal. That's what we're listening for. We want to hear that variation in the response variable from factors that are under study. So yeah, it's a long phrase, but it's a nice way to talk about it in the classroom. Okay, so next question. What types of variables make good blocking variables? And that's our next question. What types of variables, these are questions you have to have clear answers to in order to do this problem 2 from AP 2002. And not many people got this one right. Not an easy one to get. Okay, so, friends, blocking variables. If you notice there's a factor that's not under study that's making a lot of noise, if it's a factor that would be difficult to assign to someone, like you can assign to someone what kind of socks they're gonna wear. You probably can't assign puppy ownership to them. It's like either they own a puppy or they're not. You say, oh, by the way, you're gonna have to own a puppy for the next year for this. That would be difficult to tell someone. That would be difficult to assign. You could assign socks. You could assign waterproofing formula. You can, but things that are difficult to assign are gender, puppy ownerage, age, race. Those make for good blocking variables. Variables that are difficult to assign. Difficult/impossible. Whether or not you have cancer. There's a lot of things that are difficult to assign, so those become your blocking variables. So that's why in experimental designs, often you'll see, wow, there's, whether or not the person has cancer, whether or not the person has a puppy. So we could say, well, let's block it. We've got puppy owners, and then non-puppy owners. We'll just block them up front. We'll say, okay, and then from puppy owners, we'll say, okay, we're gonna randomly assign you to one of two waterproofing formulas. For the puppy owners, we're blocking by puppy ownership. Randomly assign you to either waterproofing formula 1 or waterproofing formula 2. For all these people, we get X1 bar, we get the mean amount of water that drips out after 6 months, X bar 2, and then we compare them. It's a comparative, and it could be that, and then do the same thing for the non-puppy owners. Here's your experimental design, compare. It could be that that this waterproofing formula is good only for non-puppy owners. So that reduces the scope of the conclusion. We say, yeah, well, this is a great waterproofing formula. Caution, if you're a puppy owner, then this product may fail. Lewis.
Well, you said blocking are noisy factors. And what makes a good blocking?
Well, blocking variables. See, when you have noisy factors, you want to block. Because it's like, if there's a lot of noise going on, if you just did pure randomization with these boots, it's like, wow, there's so many things that could make so much more of a difference in the response variable in terms of whether or not the waterproofing works, other than the waterproofing formula itself. Are they playing tackle football? Their activity level, basically the job that they have. That's a huge one. The job that they have, whether they go outside or not,
So
whether or not they own a puppy and what kind of socks they wear.
that is not blocking variables.
Those are not, no, those are indications. When you have a lot of noisy variables, that's an indication that you want to consider blocking. So then if you're going to say, okay, I'm going to block. What should I block by? Block by variables that are very difficult to assign. So you can't assign puppy ownership. But the biggest thing you can't assign what job the person has. And I think puppy ownership and sock type, that's like funny stuff that's fun to talk about. But when it came to the AP problem, it was type of job. What kind of job does this person have? What kind of activity levels? And that was the biggest noise. It's the biggest source of noise that students who were taking the AP test were supposed to consider. So then they had to figure out, how am I going to block in such a way so that I can deal with this so many different activity levels and so many different jobs that people have. You can't tell someone what their job's going to be. So the solution to this problem does anyone know what you would block by in order to get full credit on this AP problem back in 2002? What was the blocking variable that people were supposed to use?
Job.
So what would that look like? Yeah, okay, well, you're close, but the answer is no, it was not by job.
You can block by like labor job versus like desk job.
You're thinking in the right arena.
Indoor, outdoor.
But what you actually had to do, it's like, it's breaking it down, you know, people with this job, that job, and then it's like, but then there's so much variability, there's so much noise in there. The only people that got full credit were, yeah, Nick, do you have it?
Activity time.
Activity time, yeah, it had to get down even, yeah.
Age,
I'm sorry, age.
age.
Yeah, age you can't assign, so that would be a potential blocking variable. It came down to, and this is why so few people got it, they had to do. They had to block it by individual.
By individual
By
job.
individual person. I said people, activity levels vary so much from person to person. He said, we've got to get blocks of size 2, where there's only 2 boots per person. And to quote Floyd Bullard, he said, quote, whoa, unquote, people have 2 feet. And we have 2 treatments. Let's just take each person as a block. Let's take each let's have blocks of size 2. Let's do a, and this is a popular thing in AP Stats. It's called blocks of size 2. Also, it's so commonly used, it's called a matched pairs experiment. Matched pairs. And students' minds were just not getting there in 2002. It's hard to get there in any year, but you've got to be aware, this is a powerful experimental design. Blocks of size 2. So for all 100 people, we had 100 blocks. 100 blocks, because there's 100 people. And then what we did was for each person, we randomly assigned 1 foot, 2 treatments, 2 feet. Let's give everyone both waterproofing formulas, because some people are really, really active over that 6 months with one job, and maybe other people are not active. And there's not much likelihood that people are going to be like doing something drastically different with their right foot than with their left foot. Some people, when they're walking along the curb, it's raining, and see how one foot goes in the gutter and the other foot on the curb. Splash on the curb, splash. So they're splashing with one foot and on the other. Not many people are like that, at least not for 6 months. They might do it for a few minutes, but yeah. So you've got waterproofing formula 1, waterproofing formula 2, randomly assigned to either left foot or right foot. And then at the end, you've got amount of water 1, take amount of water 2, and then take x1 minus x2 is a difference. So difference 1. So for the first person, there's a difference in number of ounces that leak out of the boots. For the second person, there's a difference in the number of ounces. And when you got to subtract, it might be x. Let's do x left and x right.
So at that point, could they just add up all the x bar 1s and then all the x bar 2s? And then
No, okay, you know what, that's a good question. They'll take, they'll have to make it blind, they'll measure it, and then they'll open up the books and say, okay, which one was waterproofing formula A? So it actually won't be left and right. It will be, they'll look at the books to find out, because there is a record of how they were randomly assigned. They'll say, well, how many ounces came from waterproofing formula 1, whether it was on right or left? How many came from waterproofing formula 2? Then we'll get that difference. And if we always do 1 minus 2, then the difference is, suppose that waterproofing formula 1 is really, really good, and waterproofing formula 2 is lame. So there's going to be a lot of water leaking out of these. So 1 minus 2 will go negative. So if you get a lot of negative differences, then that would be an indication that waterproofing formula 1 is better. If you get a lot of positive differences, then it would be an indication that waterproofing formula 2 is better, because it'd be a lot of water leaking out minus not much water leaking out. Positive differences would favor waterproofing formula 2. But whatever it is, you could average the differences. You would get the D bar. In a matched pairs experiment, you take the average of all 100 differences and measure its distance from zero. If it's really far away from zero, that's a statistically significant result. If it's not very far away from zero, it's not statistically significant. So here is the solution that they wanted back in 2002. The solution and how to grade it. Just so you know, this is the day where you find out that matched pairs experiments is a way to do blocking with blocks of size 2. Blocks of size 2 gets a special name, and here's how it showed up on the AP test. So,
Were people not taught this before 2002?
oh, they were taught it before 2002, but it's a difficult concept. And so when you get problems like the waterproofing boots problems, where nationwide people score really low on that problem, then it gets the attention of the AP Stats instructors, and they say, what are we going to do? And Floyd Bullard has led the way. So let's teach students about the concepts of signal and noise, and that might help them think more effectively about this. So notice the solution. They had to say a paired design in which each student receives a pair of boots where one boot is treated with the new method and the other with the current method. Subjects should be randomly assigned to one of two groups. Group 1 would have the new boot applied to the right boot. Group 2 would have the new method applied to the left boot. Or they could just have it just for each person. It's determined at random. Now the crossover design, that's what some students thought of that back in 2002, and so they gave them credit for that. But we don't have to go into the crossover design. And then could it possibly be double blind? The answer is yes. You could. The people who are wearing the boots could be blind as to which one has which waterproofing formula, and the people who are measuring the results could be blind as to whether this boot is dripping out water, it had waterproofing formula A or B. And then how they graded it with EP&I is also included. The EPI grading for each one is given. And notice that if you just said completely randomized design, the most you could get was a P on this. The only way to get an E was to say basically matched pairs design, blocks of size 2. So it's not, and as I was listening to where you were going in your mind in terms of how are we going to deal with the noise? How are we going to manage the noise? You went to smaller groups, blocked by job, blocked by age, all these other things, but to go down to the individual blocking. Blocks of size 2 also come up sometimes in marriages, where they say there's so much variation from family to family. Let's look at the difference between the husband and the wife. So husband, wife, matched pairs experiments are very common, or before, after. We'll take an individual person. We'll measure the response variable before the treatment, and then we'll compare them with themselves after the treatment. Those were showing up in the examples in the textbooks, but never before did people have to say, oh, whoa, 2 treatments, 2 feet.
Where does Floyd Bullard teach out of?
Yeah, you know what, I don't know. I mean, he's like all over the place on the AP Stats comment boards. He's like commenting left and right on everything. But I've never actually asked myself where he's teaching. I'm sure Floyd Bullard, spelled Bullard. It'd be easy to Google him and to find out, where he's hanging out.
I'm thinking maybe a field trip here.
Yeah, to go and meet Floyd.
Yeah.
And check out his.
If he's close, within 6 hours or something.
Like 6-hour plane or
Yeah.
boat ride or car ride?
Yeah.
Car ride? Okay.
All right.
Oh god. Yeah, let's do it within a 6. We have to go to the place, but if it's a 6-hour boat ride.
All right, so ladies and gentlemen, you're in good shape now to do the homework that's due on Monday.
Is that on the calendar?
And it's on the calendar, and what you got the handout.
Yeah. Okay.
It's online, it's everywhere.
Thank
Okay,
you.
so thanks for coming today. Have a good night.